Talat Farm is a farm management platform based on smart poles and drones designed to enhance agricultural productivity and optimize energy use. When a work location is selected on the farm map, an optimized drone route is automatically generated. Real-time data is collected by equipping drones with multispectral cameras. With the collected information, the NDVI index is analyzed to systematically manage crop growth conditions. When the drone's battery runs low, it utilizes a wireless charging system connected to the smart pole to recharge. The smart pole generates electricity through solar and wind power, providing automatic charging. Additionally, environmental sensors collect weather and environmental data along with power generation data. Through the use of AI, weather conditions, NDVI index, and power generation are collected, analyzed, and predicted to build a forecasting model aimed at improving agricultural productivity. Leading the future of high-efficiency agricultural automation and eco-friendly energy management.
Ecoklebin happens to be one of the smart pole product lines our company is currently developing. Unlike a conventional streetlight, you can think of it as a streetlight powered by renewable energy. The Ecoklebin, which our company is currently developing, integrates 3 distinct multi-source methods to generate energy. These include an Archimedes system wind turbine positioned at the top, a cylindrical solar panel located in the middle section, and a seawater power generation system situated at the base. By simultaneously utilizing these 3 power sources, we were able to secure a notable power generation capacity. Ecoklebin was developed with the aim of achieving complete automation in drone operation. To autonomously operate drones, automating the power supply is of utmost importance. However, charging by drawing power from an external source has high installation costs and is difficult to deploy. That's why we needed a device that could gather power on its own, the Ecoklebin. In the case of existing smart poles based on renewable energy, they are often utilized in a way that adopts a single power source. Also, they are often linked to the existing power grid and used as a source of auxiliary power. In contrast to competitor products, our Ecoklebin stands apart by being able to function as an off-grid system, entirely independent of the pre-existing power infrastructure. If multiple Ecoklebin smart poles are installed within the same area, we are currently developing a platform that will enable an operator to remotely manage and monitor numerous Ecoklebin units from a distant location. Furthermore, our ultimate goal is to establish this as a valuable platform asset, one that can be effectively utilized for the dynamic practice of power trading.
To concurrently gauge the output from solar, seawater, and wind power generation, we linked 5 power modules. This, however, resulted in intricate wiring, which regrettably caused signal interference and various connection errors. To solve this, we modularized the wiring into an integrated connector structure and applied a noise filter to improve the system for stable data collection.
The electrochemical method of seawater power generation used in the Ecoklebin was a relatively unfamiliar concept, so it was difficult to assess its feasibility. Therefore, we meticulously researched the theoretical underpinnings, iteratively performed extensive small-scale unit testing, and subsequently finalized a pragmatic yet adaptable design, leveraging the patents held by our company.
One of the key components of the Ecoklebin is the wind turbine installed at the top. A major challenge was the structural design, which had to allow the lower shaft of this wind turbine to rotate naturally while remaining fixed and prevent the internal wires from twisting with the rotation. This area required significant improvements and extensive testing, particularly for the structural design of the lower section and the use of a slip ring. Currently, the Ecoklebin is built in a low-profile form, focusing on drone communication and power facility operation. However, moving forward, our plan is to expand the structure to the height of a regular streetlight, boosting power generation. We also aim to develop it into a more practical self-generating communication platform by incorporating additional equipment.